In this DSP lab related to 6713 DSP kit, earlier lab we understood that how to use Code Composer Studio of Texas Instrument as a simulator. So in this lab we will be discussing how to use this TI DSK 6713 DSP kit. Under this headings we will be doing two things. One is generating a sine wave for required frequency, and the other one is receiving an external signal and process and give us output. These two things we will be discussing. So let us review what we discussed in the previous class, use of CCS as a simulator, in which what we have done, we have written a C code using Code Composer Studio to generate a sine wave and simulate. So this is typically what you have written a C code when using Code Composer Studio, and when you simulated this, you got generate the samples of the sine wave like this. You plotted the sine wave and you found out this is what is the sine wave in the previous class using the Code Composer Studio. So in this class in the previous class we also discussed that the use of Code Composer Simulator is useful to simulate any code, because when you don't have the DSP kit and you know the algorithm, you want to check whether the algorithm will work or not. For that purpose you can use a simulator. But when you will have the kit, then only we can test whether it is working or not. So today we will be understanding, we'll be trying to use the same C code which you have used in the previous class to generate a sine wave, and generate actually sine wave using the DSK kit. Let us go how to do that. Before going to that, let us discuss little bit regarding the DSP kit. I hope I am not putting not obstacle on path of camera. Okay, fine. This is what is the 6713 DSP kit. You can see there is a codec available which is called as the AIC23 codec in 6713, which is having 4 lines. Those lines are mic in, mic out and line out. So you can see here, this is what is mic in, line in, and these are the 2 output ports, mic out and line out. So using this you can give input, and using the line outs you can, or HP out, you can take output. So line in and line out for audio signals, mic in and headphone out are for stereo signals, and except that you can also control the sampling rates of this DSK kit in this codec as 8, 16, 24, 32, 44.1 and 48 and 96 kilohertz, depending on what is the required input signal or output signal. You can change the sampling rate. You know what is meaning of sampling rate. If you will change the sampling rate, if you will have a less sampling rate, you will have to do less computation. If you will have more sampling rate, you have to do more computation. But if the frequency of the input signal is higher, then we have to go for a higher sampling rate. Okay, you will discuss do some exploration in the experiment using this sampling rate. And one more thing which you will, if you look into the DSP kit, you will find out this LED and dip switch. These are used to give some binary inputs. LED will show you what is the output, through the dip switch you can give the input, and this LEDs also will be helpful to test during the testing phase of the DSP kit. So which will be explained by our research scholar Apurva. use of DSK kit with DSK kit. In this we will receive an external signal. In this experiment we will receive an external signal, process and give us output. Okay, in this let us see. External signal means we will be generating this external signal using a signal generator, not using a signal generator, right? So in this, so generate a sine wave. Let us first generate a sine wave. We will be generating a sine wave of 1 volt peak to peak by an external signal generator. Why it is 1 volt? Because the maximum input voltage that it can take is 1 volt peak to peak. It's better to have an input voltage range from 500 millivolt to 1 volt peak to peak to give to the DSP kit. After that, generating this thing, you will receive the signal through this AIC23 codec line in, and then do required processing. Presently we will be doing amplification. You can amplify the signal by a factor of 5, 10, 15 and see how the amplified signal looks like, and give output through the AIC23 codec line out. Basically we are doing only one type of processing, but you can do many type of processings, like similarly you can do filtering, rectification, music enhancement. The way you write the code, accordingly the processing will be done. As our objective here is to how to work with the DSP kit to get the input, do simple processing of amplification and give the output. That is why we will be limiting our presentation, our experiment today only with amplification. So except that, one more experiment also we will be doing with experiment on changing on sampling rate. If we change the sampling rate, how the inputs, how the outputs from the DSK kit will change, you can see through that. Thank you. I shall request our research scholar Apurva to go through the experiments in the next step. Thank you. Stop.
Line output, headphone output is a processor DSP. It's operating. It's operated with the 225 megahertz, and ST-RAM is 16 MB. DC power input, USB port, DIP switches, LED switches, reset switches is the physical layout of C6713 DSK. So first, how to connect the DSK to your PCs is a most important thing. First, connect the supplied USB cable to your PCs. It means USB cable to your PC or laptop, anything. If you plan to install microphone, speaker or expansion card, this must be plugged in properly before you connect power to the DSK board. Connect the included 5 volt power adapter to your AC power source using the AC power cord. Apply power to the DSK by connecting the power brick to the 5 volt input on the DSK. When power is applied to the board, the power on self-test or post, we can say that post will run. LEDs 0 to 3, we have 4 LEDs, so that's why LEDs 0 to 3 will flash. When the post is complete, all LEDs blink on and off, then stay on. At this point, your DSK is functional and you can now finish the USB driver install. So after doing this, connecting the DSK to your PCs, we have to check our DSK is working properly or not. How to check this DSK is working or not? So first click on this icon C6713 DSK diagnostic utility and press start. So, it's automatically starts the USB diagnosis. It's automatically diagnoses USB port, DSP diagnostic, external memories, flash diagnostic, codec diagnostic, LEDs and DIP switches. And afterwards, if it's passing all these diagnostic tests, then it's not ideal. It will showing pass. If it will be showing fail, it means your connection is not properly, your connection is wrong, it means it's not connecting properly. So we have to connect again USB ports and switch it off for 2 minutes for few seconds and then again start. So simple DSK kit here, 2 inputs and 2 output. One is line in and line out. Another one is headphone output and microphone input. This is the DSP processor. It supports 224 megahertz frequencies. Another one is your AIC codec pin. Is already written here, AIC codec, and one USB port, DC supply. All the things are in this board. LED switches is here, reset switch and DIP switches, and it's an expansion card, it's a slot. So this is the simple physical layout of your DSK kit. So first we have to so we will do 2 experiments based on this DSP kit. One is your sine wave generation and another one is processing of external signals. Processing of external signal by using function generator. So now start with this, how to start work with this CCS DSK kit, how to start work with this DSK kit. So first click on this C6713 DSK Diagnostic Utility version 3.1. Then start. So here fail, it means connection is not proper. So we have to connect again, stop, close, and then switch it off for some time and then again start. So click on this C6713, start. So waiting for USB enumeration. Passes. DSP diagnostic, external memories. Flash diagnostic. So LED is blinking here. When passing with this LED's diagnostic, is blinking, or it's continuous on LEDs, DIP switches and all. So it's on constantly. Afterwards, stop and close this DSK diagnostic. It means your DSK is working properly or work fine, no problem. So close this and click on Setup CCS Studio version 3.1, or directly we can click on C6713 DSK CCS Studio version 3.1. So click on this C6713 DSK. Here no target connected, so don't bother about this target. First we have to create one new project. New project name is any sine wave generation port, so sine wave. So here make a new folder on desktop. Folder name is new folder name is sine wave. And okay. So I shall use the same code I have used in sine wave generation in simulation mode. I shall add some additional files to the make DSK kit working. Include the same files in my C code, explain some details regarding the files, sampling rate definitions, codec open, writing into codec, reading from codec, etc. I shall add some additional lines to make DSK kit working, like for sampling rate control, how to open codec, writing sampling code, writing samples to the code, why 2 times, why it's less than 2 and more than 2, and close codec. It's some basic things related to codec I'll discuss. Executable target should be 67. Okay, and finish. So here project is included in this project directory. Then next one is we have to write some code. So first open new project. Second one is create a new source file. Here we have to write some C code. C code is any sign code. It's a simple sine code, sine wave generation code. Save it inside the same folder, sine wave. Sine wave.c. It's a sine wave generation code using DSK. Here the experiment on receiving sine wave and processing that, it means the input can be given, maximum is peak to peak 500 millivolt to 1 volt. Generate sine wave of 1 volt peak to peak of an and check with CRO. This is to be given to DSK. How to connect the signal to DSK, modify the program, explain the significances of addition of each line, amplify the signals and observe the output is the main objective of our sine wave generation. And then next we will proceed with some effects of changes on sampling rate. So this is the sine wave code. Save as, press Ctrl S and save it and add it in same folder, same project name, sine wave.project. Add files to project, sine wave, open. So it's already added here. We have to make sure we have to include some board support library file. One is the DSK 6713 header file, another one is AIC codec file, and one board support library file. So we first include board support library file. So follow this path name, go to the local disk C, CCS Studio v3.1, C6000 family, click on DSK 6713, click on live, file of type is all files, and then select DSK 6713 board support library file, open. So here it's included. Another file name is, another thing, we have to include 2 header files. So again go to the my computer, local disk C, CCS Studio, C6000, DSK 6713, include this folder. We have to copy this file. So one is AIC codec file, another one is header file. After including this file, we have to use one of the most important thing is a DSP BIOS configuration, because we have already included board support library files, DSK header file and DSK AIC codec file. The next step is DSK BIOS generations. We have to include DSK BIOS configuration file. What is this DSP BIOS? configuration. It means DSP BIOS allows you to develop embedded real-time software applications for Texas Instrument TMS 320 DSP device. BIOS is a basic input and output system. It automatically converts your software to hardware implementation or something, a hardware interface. So for how to include this DSP BIOS configuration in our file? So first click on File, New,
Okay, start.
Now next step is DSP BIOS configuration. So click on File, New, DSP BIOS configuration. We have to select our particular DSP kit, that is DSK6713.cdb. After that, OK, click on OK. So it's a configuration file. Then save it, this file, configuration file. Press Ctrl S or you can give any file name. Name is like here XY. Name is X, Y and Z and save. So here, save your configuration with the name of XYZ. Then our next step is add this configuration into the project. We have to click on and select the configuration file. So we have to click on this sinewave2.project, right click, add files to project, and the configuration file of type is all file. Configuration file is name is XYZ. So we have to select this XYZ. Open. So it's already included in project directory here xyz.cdb, and it's already generated 3 files. One is xyz cfg.cmd, another one is afg file and c file. So this is the simple code for sine wave generation. Every time if we are making our project file with DSP BIOS, we have to include that file into the project. The file name is here. This file name is xyz cfg.header file. Every time we have to include this file name xyz cfg. It can be any name, xyz cfg or os, but extension should be .h with configure file cfng, like os cfg.header file. Any name you can use here, xyz os, any name with configuration.header file name. Another one is, so include this file in our project. So our DSP BIOS configuration is over. Then we can again build it. Rebuild all. It's showing there is no error. Then next step is now we can simply go into the file and load program, debug. Inside the debug file name is sinewave2.out. Load it, open. Now it's burning the program into your DSP kit, and after that debug and run. So here sir, so this is sine wave generation using DSP BIOS configuration with frequency is 4 kHz. So now next step is Now I'll explain this simple code how to write in DSK kit. First, so we have to include C6713 board support library. Board support library has several modules, each of which has its own included file, like DSK6713.header file, AIC codec header file. So DSK6713.header file, DSK673 AIC codec file. The file DSK6713.h must be used in every program that uses the board support library. DSK6713 AIC codec is another file name. It will support all the codec file like DSK67313 configuration file, open codec, how to open, how to write, how to read the codec file. So already here written. So first in a slice or first define our parameter for the DSK6713 AIC codec. Is a by default configuration name is DSK6713 AIC23 default configuration. Second is how to handle this codec. For this codec handle, we will use DSK6713 AIC23 codec handle. H codec is a by default AIC codec name. Then start codec. For start codec is open the codec. It means it's a by default configuration name is DSK6713 AIC23 open codec. In every program we have to define these three or four files. First is configuration, another one is codec handle, third one is open configuration or open codec, and fourth one is close codec with some writing and reading files. Another one is frequency definition. DSK AIC codec set AIC supports different frequencies. It supports 8 kilohertz frequency, 16 kilohertz, 24 kilohertz, 32 kilohertz, 44 kilohertz, and 48 kilohertz, 96 kilohertz. Maximum frequency is 96 kilohertz. Is a by default frequency definition for AIC codec. And finally, write our program in within this codec open and close codec. Here frequency is divided by this frequency f by fs. Here fs is your 48 kilohertz frequency, 96 kilohertz frequency, 8 kilohertz frequency. We have to define this frequency with f divided by fs. Fs is anything. It depends upon your AIC codec frequency, like 8 kilohertz, 16 kilohertz, 24 kilohertz, 48 kilohertz, and 96 kilohertz. Then afterwards, make one while loop. It's an infinite loop. Then use for loop and write your codec. It's a read, and then after write codec. B is your output name. H codec.b. It's a by default name used by AIC codec. DSK6713 AIC23 write H codec and comma output name. Name is B, C, anything. And finally, close codec. It's a simple sine wave generation code. Included all the header files with your open configuration and close configuration, and also frequency and also some frequency we want to add and remove this frequency, like a 48 kilohertz, 24 kilohertz, and final sampling frequency is your f by fs. Fs is your 48 kilohertz, 16 kilohertz, and anything depends upon AIC codec. It's a simple code for sine wave generation. The next one is now the next example is processing of external signal. What does this mean of external signal? It means the TMS 320 6713 DSP processor can receive an external signal and process it. Here we are talking about generate a signal of 4 kilohertz, 4 kilohertz sine wave and 200 millivolt peak to peak signals using the function generator. Function generator is used as a generate external signal. So for this purpose we have to connect function generator to line in. Line in, it means line input, and then write a code. All the steps are same, but here only code is different. Only all the things are same, like include header file, DSK 6713 header file, and .h file, codec file, configure, open and close. But here we have to define two inputs. One is left input, right input, left output and right output. In the case of external signals generation, line input, it means left input should be equal to left output, or right input should be equal to R output. So here write one program for this. Line output or left output is equal to, with amplification, some amplification with L input, and generate signals. Like L input is 4 kilohertz frequency, it means multiplied with 10 and generate your output. We can observe our output in CRO. CRO generates a sine wave by using this all the functions, all the codec function, and write a simple code in C. So it's a reading part and a writing part. Reading, it means first read it from left input and right input, and write to left output and right output. Is a simple code for external signal generation. So thank you. Enjoy.